determinant of a 2 by 2 matrix. First, you need to understand determinant concept. A determinant is a scalar value that can be calculated from the element of a square matrix. A square matrix have the same number of column and row, like a 2 by 2, 3 by 3. Yes. It is used in various areas of mathematics, such as solving system of linear equation or simultaneous equation, finding the area of a shape like a parallelogram, and understanding matrix property. The scaling factor of transformation represented by the matrix. If the determinant of the matrix is 0, that is if AC minus BC equals 0, the matrix is called a singular matrix. A singular matrix is a special matrix in that it does not have an inverse. It is also indicates that the system of equation from which it is derived has no unique solution. Whether a matrix has an inverse, if the determinant is 0, the matrix has no inverse. Like this example. Finding the determinant of a matrix. To find the determinant of a matrix, you know that matrix can be written as DET bracket A or the absolute of A. That is when they ask you to find a determinant. They will use either symbols. The formula for the determinant of a matrix is AD minus BC. So to find the determinant, first you write out the 2 by 2 matrix, which is you have 1, 2, 3, and 4 here as matrix. We are going to apply the formula. The determinant is simple, AD minus BC, as you see in there. So you're going to do A times D minus C times B. So you have the matrix 1, 2, and 3, 4. So to find the determinant of that matrix, you're going to multiply 1 times 4 minus 3 times 2. So the order of operation applies is that you multiply the diagonal first, then subtract. So here you get 4 minus 6, which is equal to -2. The next step is that we're going to practice. The more students practice, the more comfortable they will become with calculating the determinant.
The determinant of each matrix. I want to find the determinant of each matrix. Now, I know that the determinant is going to be a real number based on this matrix. This is a 2 by 2 matrix. 2 by 2. So that means that this matrix has 2 rows and 2 columns, with the row number always coming first. So how to find the determinant is you use the main diagonal and the counter diagonal. So I'm going to draw a line through the main diagonal. It's going to cross through 6 and 4. So I do 6 times 4. Now what I want to do is I want to use the counter diagonal, which is the diagonal running in the opposite direction. It's going to hit 2 and 5. So we need to do 2 times 5. So we multiply those two numbers together, and I always put a subtraction sign in between because we're always going to be subtracting at the end. 6 times 4 is going to give you 24. 2 times 5 is going to give you 10. And then 24 minus 10, that's going to give you 14. So my answer is 14. That's the determinant of that matrix. Let's try the second one. This is also a 2 by 2, so I need to use the main diagonal first. When I draw my main diagonal, it's going to go through two numbers, -2 and +4. So I need to multiply those together first. Then I'm going to multiply the numbers that are on the counter diagonal, the 1 and the 7. So I'm going to have 1 times 7. And I always put the subtraction sign in the middle. -2 times 4 is -8. 1 times 7 is just going to give me 7. And -8 minus 7 is going to give me a -15. So that's going to be my determinant, and I circle that. Down here, I have another 2 by 2. I'm going to use the main diagonal first. That's going to be -3 times 0. Put the subtraction sign in the middle. And now I do the counter diagonal. It's going to go the opposite direction, and it's going to pick up -1 and -2. So I need to multiply -1 by -2. So when I multiply -3 times 0, I'm going to get 0, because anything times 0 will give me 0. Minus, bring down your subtraction sign in the middle. Over here, I have -1 times -2. That's going to give me a +2 when I multiply. So now I have 0 minus 2. That's going to give me -2. Now for the last one, I have to find the determinant of this 2 by 2. I start off by using the main diagonal. I scoop up 1 and 2, so that's what I'm going to multiply first. Put your subtraction sign in the middle. Now we're going to use the counter diagonal to get 1 and 2. So those go next over here. So 1 times 2 over here is going to give me 2. Minus 1 times 2 is also going to give me 2. And 2 minus 2 is going to give me 0. So my determinant for this one is going to be 0. What you'll find out later is that when your determinant is 0, that means that you cannot invert this matrix. So we call this matrix non-invertible. Non-invertible. What that means is that you can't invert it. You can't make an inverse of this matrix. We also call that singular. Singular.
So determinants are used in solving system of linear equation. Show them how the rule is used in determinants. So take a look at this example.
Where x and y are variables and the other letters are just coefficients. We want to know if this system of equations has a solution, so that there is a certain value for x and y, so that this system of equation is correct. We can do this by using a determinant. To find the determinant, we take all the coefficients of our variables and we put it in a matrix. The determinant of this matrix determines whether this matrix or system has a solution or not. We multiply each element on the green line, so we have A times D. Then we multiply each element on the red line, which is B times C, and we subtract it from the green elements. We have this system of two equations. The first step is to put these coefficients of our variables x and y into a matrix. Then, the determinant of this matrix, which can be denoted with these straight lines, is given by the multiplication of the elements on the green line, so 5 times 3, and we subtract the multiplication of the elements on our red line, which is 8 times 2. Then all there is to it is to simplify this, so we have 15 minus 16, which is equal to -1. And we know that if the determinant is not equal to 0, then there is one solution. Now we have this system of equations. The first step is to put all these coefficients of our variables into a matrix again. The determinant of this matrix, which can be represented by these straight lines, is given by the multiplication of the elements on a green line. So we have 2 times 9. And we subtract the multiplication of the elements on our red line, which is 6 times 3. This is equal to 18 minus 18. So this is equal to 0. Now we know that if the determinant is equal to 0, then there is no solution.
Trick interpretation. In 2D shape, the determinants of a 2 by 2 matrix can be interpreted as the area of a parallelogram formed by the column vector. Look at this proof and follow along with an example.
Area of a parallelogram using matrices. The parallelogram has 4 corners at 0, 0, -1, 1, 2, 3, and 3, 2. Notice that I've also drawn 2 vectors, the vector 1 from the origin to this one corner, and the vector 2 from the origin to this corner right here. We can now draw those 2 vectors, at least numerically represent those 2 vectors as matrices. Vector 1 can be represented by a matrix as follows. It will have the elements x1 and x2, and in this case that would be equal to x1 would be 3 and x2 would be 2. So x1 and x2 in essence stand for x and y. And vector 2 can be represented as follows. That is equal to, again, x1, x2. That would be the variables x and y in this case. And in that case, we would have -1, 1. So -1 and 1. We're now going to create the matrix A from those 2 vectors. We now can represent the matrix A as being equal to vector 1 in the first row and vector 2 in the second row, which becomes 3 and 2 for the first row and -1 and 1 for the second row. It now turns out that the area of the parallelogram can be defined as the determinant of A, which is equal to the product of those 2 elements, 3 times 1, minus the product of those 2 elements, 2 and -1, which is equal to 3 plus 2 or 5. That means in this particular case, the area of this parallelogram is equal to 5. It's
Error in determinant of a matrix. When solving determinants of a matrix, especially for 2 by 2 matrices, students often make various common errors that can lead to incorrect results. So error number 1, incorrect use of determinant formula for 2 by 2 matrix. So the common error in a 2 by 2 matrix is that determinant should be calculated as AD minus BC, but the common error is they mix up the signs or misapply the formula, such as using either AC minus BD or AD plus BC, but the correct formula you should be using is AD minus CD. So A times D minus C times B. The second error is arithmetic error in multiplication and subtraction. So, when performing multiplication and subtraction involved in the determinant calculation, students may simple arithmetic error. For example, they might compute by 4 times 7 minus 5 times 8, so 28 minus 40 is equal to negative 12. But instead, they incorrectly write negative 28 or 12 instead of negative 12. How to avoid this? So students are to work step by step and write out each calculation clearly. If possible, have them check their arithmetic by verifying calculation or using a calculator for the steps. Another error is not recognizing zero determinants. So the common error is that sometimes students fail to recognize that a matrix with a certain property, example like identical row or column, or a row or column of zeros, will have a determinant of 0. So for example, you have 2, 4, 2, 4. So this determinant of this matrix is 0 because the row are identical, and student might spend unnecessary time calculating it as if it were non-zeros. So students are to recognize pattern in matrix like repeated rows or column and emphasize that these often leads to zero property or zero determinants. The next step is that practice CSEC type questions. Take a look at these past paper questions. So take your time and calculate these step by step. Here are the solutions for question 1 to 4. Real-life application of determinants 2 by 2 matrix in the real world.